A very good morning, my dear students. Today I would like to give a brief explanation about fifth unit, that is simulation. So in this unit we have to understand what is simulation and why it is useful and how we will do the simulation process. And next, types of simulation we have. Under that, Monte Carlo simulation is one and what if analysis is another one. And before going to start about Monte Carlo simulation, first we have to understand the concept of random number generation. Why it is needed means, for Monte Carlo simulation, first we have to understand how randomly we are selecting the data. So for that purpose, random number generation is needed. And next we have verification and validation, differences between verification and validation. Then we have advantages and disadvantages of simulation, risk analysis. These two concepts we have to understand. Then finally we have decision tree analysis that you have already studied in operations research.
Now I would like to say the definition of simulation. Simulation can able to test the systems virtually before an organization going to take some particular decision. That means which represents a real world data in a computer model by giving some instructions to the organization with the help of that particular data model. That means simulation can able to give the duplication or replication of the real world data virtually to take some informed decisions, so that the organization can able to make the decisions perfectly. Simulation can able to test the systems virtually before an organization going to take some decision. That means which is a computer model that mimics the real world system or scenario, which mimics the real world system in computer by using a model which is the virtual data, providing for organization to take some informed decision. That is the definition of simulation. I want to say about when we have to use the simulation techniques. So when the time of multiple factors contributing to a decision, multiple factors we have to observe at that particular situation, we can use the simulation technique. When there is a significant time delay, there is a time delay chance may be there, at that time we have to use simulation technique to get faster results. When a simple mathematical calculation is not enough at that particular situation, also we can use simulation technique. And the next concept I want to say about how it works, how simulation works, I want to say now. First step is identifying factors. What are the factors affecting the real world data? That first we have to identify. Then creating a model is the next step. We have to create a model for simulation by using some techniques. Next I would like to say about that. Now about next step, run the simulation model. Then run the simulation model, finally analyze the results. 4 steps we have to understand in the working procedure. Identifying factors is the first one, creating a model is the second one, run the simulation model is the third one, analyze the results is the fourth step. These 4 steps we have to follow while applying simulation model. Next, listen here. Applications of simulation in data analytics. Supply chain optimization is the first application. Here we can understand simulating different inventory levels. That means a supply chain means from manufacturing to marketing. How the steps will go in optimization way. That means simulating different inventory levels, how we can manufacturing and what we can manufacture, what are the good transportation techniques or routes, and demand patterns. What are the demand patterns for that particular product we can understand by using the simulation techniques. That means virtual data we can collect from the various scenarios in the real world system, and by observing those from the existing and proposed systems, then we can apply those for getting good optimization in the supply chain management. So in that way we can achieve the goal. Good decisions we can take in supply chain optimization. Next application is financial modeling, predicting market behavior and assessing investment risks by simulating different economic scenarios. That means by financial model by simulation techniques we can improve the financial model. That means predicting market behavior, how the market behavior and how the investment risk will going on. By collecting real world risk scenarios and virtual model in computer based model, we can collect the data from real world scenarios without disturbing the real world system. We can collect from the data from past, present, and then we can give the model, and we can analyze the model by past data and observing present, then future prediction we can give from that model. Virtual model we can give the future prediction, then a good decision in the financial modeling we can achieve. Next application is healthcare planning. While coming to the healthcare, here we can observe the data which is related to hospitals and optimize the results allocation. That means we can reduce the waiting time in the hospitals by collecting the virtual data from the various hospitals. So from that we can make a model to reduce the waiting time and to improve the resources in the hospitals. Next one is marketing campaign analysis. Here evaluating the impact of different marketing strategies. What are the different marketing strategies? We can observe from the virtual data we collected from the real world scenario, and we can make a model in the computer to get the good result by using simulating techniques. Then next listen here students, data analytics professionals should know these 4 types of simulation models actually. Those are Monte Carlo method, agent based modeling, discrete event simulation and system dynamic modeling. These are the 4 types of modeling techniques generally we have. While coming to our syllabus, we have 2 kinds of simulation techniques. Those are Monte Carlo method and another one is what if analysis. These 2 kinds of simulation techniques we have to understand in our 5th unit. Next we have to go through with Monte Carlo simulation. In the case of Monte Carlo simulation, here this is the mathematical technique that uses random variables or random sampling to predict the possible outcomes by past data. To predict the possible outcomes by past data, we have to observe the random variables by collecting from the technique random number generation. So here by using the random number generation we can understand the concept of Monte Carlo simulation, because here we have to select random samples. So for that random samples, how to select a random numbers from the large or huge amount of data. So here we can understand that random number generation in the next concepts, in the next further explanation. Now I want to say about Monte Carlo simulation with the help of a screen. So now I want to share this screen. Monte Carlo method, which is originally named after the Monte Carlo casino in Monaco. So because of those persons' name, Monte Carlo casino in Monaco, we got the name of Monte Carlo simulation. We have Monte Carlo simulation and what if analysis simulation. Both we can understand now in our syllabus, and which are widely used in fields such as finance, engineering, supply chain, as I told previously in the case of applications of simulation. Now I want to say about Monte Carlo simulation. What is Monte Carlo simulation? Which is a mathematical technique and which is completely probabilistic, and while coming to the what if analysis, that is deterministic technique. And here probabilistic means probability distribution we have to use for random variables. We have to select from huge amount of data, a complex set of data. We have to select a random samples, and random data we have to select by using random number generation technique. Then after collecting the random variables, and we have to apply that random variables probability distribution techniques, and then we can get some simulation model. And this process is repeated many times to create a distribution of possible outcomes. Then finally we will get uncertainty, model uncertainty as the first step in this Monte Carlo simulation, and next one is random sampling, and next one is simulate outcomes, and next one is analyze results, and one after the other I will say. First step, model uncertainty, and define how each variable can vary using probability distribution. By using probability distributions, how each variable can vary, so that we can understand in the case of model uncertainty. And next one is random sampling. Randomly select values for these variables based on their distributions. Randomly select values. So from that we can select random sampling is the second step. Model uncertainty is the first step, and next one is random sampling. And third step is simulate outcomes. And use these values, we can simulate the model by simulating model whatever we design in the case of Monte Carlo simulation. And next one is analyze the results is the last step as usual in the case of simulation steps. And next one is in previous classes, also in the previous units already I said about random variables. What is a random variable? Which is a variable in the random which we can select randomly, that is called as random variable. These are of two types, discrete random variable and continuous random variable. While coming to the discrete random variables, we have to take a discrete values or discrete variables. In between there are no continuous intervals. In between the values there are no continuous intervals. For example, number of items, number of persons, we cannot take in decimal values. Discrete values only 1, 2, 3 like we can take. So that is why that is discrete random variable. In middle we cannot divide the data into continuous variables, discrete continuous values, intervals. We cannot divide that two points, two variables, two data points into discrete continuous values. That is why that is discrete random variable. And next one is continuous random variable. In the case of continuous random variable, these variables can vary. In middle we can divide the data points or data variables into discrete continuous intervals, continuous variables, that means in decimal points. Example, height and weight 23.5 kgs. Likewise we can take. So that is why continuous random variable containing continuous intervals in between two discrete values. That is why that is continuous random variable. Example is height and weight. And next one is probability distribution. Already I said normal distribution, you know. So in the case of probability distributions, normal distribution is most commonly used distribution in statistics, and central limit theorem. Here I want to say once again about normal distribution. Here what is normal distribution theoretically means all the values, all the data points which are symmetrically distributed around the mean value. So that is called as normal distribution, and this showing curve shows the normal distribution in probability distributions, and central limit theorem follows normal distribution. Next one is using Excel. So by taking an example, I want to explain the example. And also we can use Python, R, SAS and MATLAB to help for simulation techniques. And now here we are going to understand the functions related to the Excel in this. So in Excel for simulation purpose, Monte Carlo simulation purpose, random and norm.inv covering their syntax parameters, and typical use cases also we can use here. The syntax for rand function is like this. There is no need of any parameters, just random of RAND of function we can use for this purpose. So the parameters we can understand here. The parameters are probability. The probability corresponding to the normal distribution we have to take, and which must be a value between 0 and 1. This already we know. And this is typically generated by the random of function. Rand of function, mean, the arithmetic mean of the normal distribution, and standard deviation we have to take. The standard deviation of the normal distribution is a measure of how spread the numbers are around the mean. How the numbers are spreading around the mean is standard deviation. Mean already we know. Number of observations, sum of observations by number of observations is the formula for mean, that already we know. For normal distribution we have to take mean. And standard deviation, how measure of how the values are spreading around the mean. Now we have to take the example here. So here an average demand of 10,000 units for new devices, that is mean value is 10,000 with a standard deviation of 2,000 units. And here given that unit sale price typically ranges between 50 and 70 depending on the competitive pricing in the market saturation. And also given that the unit cost influenced by volatile material prices and manufacturing efficiency averages rupees 30 per unit with a standard deviation of rupees 5. These two things are given like this. Now we have to apply Monte Carlo simulation in the Excel sheet. First we have to take the columns demand, sale price, cost and profit in your Excel sheet. So for that, prepare your Excel sheet worksheet to include columns for each variable and a column for the calculated profit. Next step is input formulas for variables. So demand, normal distribution of mean is equals to 10,000 units and standard deviation already given that 2,000 units. And sale price, uniform distribution we have to take rupees 50 to rupees 70. And cost, normal distribution of mean is equals to 30 and standard deviation is equals to 5. These are the things. And input formulas for the variables we have to give like this. Norm NORM dot INV of random of 10,000 comma 2,000. Like this we have to give the formula. In the Excel we have to give like this for normal distribution. So in the next step it will calculate like this. The above equation creates a normal distribution. So for creating normal distribution we are using the function norm.inv. So this particular syntax we must follow in Excel sheet. Random of is for random variables and NORM.inv is for normal distribution. This particular syntax we have to remember. So we have to create columns first and give the data, then formulas we have to give for creating normal distribution. Next, third step is calculate the dependent variable. So dependent and independent variables is also most important to understand the simulation concept. Now calculate the profit, which is the dependent variable. Dependent variable means the target variable. What we have to find out? We have to find out the profit. So that is the dependent variable. For each simulation using the formula and column D. So here column D is profit we have taken. So that is the dependent variable here we are taking, and three independent variables are demand, sale price and cost. Those are predictor variables. And next, fill down to simulate multiple scenarios. So we have to for done is to create a single simulation. Let us extend it to multiple. So let's say thousands of simulations. Select cells A2 to D2 and drag the fill handle and small square at the bottom right of the selection. So if we drag, we will extend the data to the multiple values. Then finally step 5 is analyze the results. So after running the simulations, you can analyze the results using statistical functions such as mean, max, average and standard deviations. Don't hesitate to quickly refer to the Excel cheat sheet for a refresher on the built-in Excel functions we will use next. So in this way we can find out like this: min, max, standard deviation, all values, average profit, minimum profit, maximum profit. So in this way we got the answers like this. Just understand the concept by using Excel sheet, how we can use and what are the functions, what is the exactly syntax. That is most important thing we have to understand for each and everything in business analytics, whatever from starting we are doing. Next we have what if analysis, and which is also a decision support technique used to predict the outcome of different scenarios, and this is completely deterministic, not like Monte Carlo simulation. What if analysis is deterministic, and here principles of what if analysis are evaluate how changes in input variables affect the output system in a deterministic manner, and steps involved here are identify input variables or predictor variables, and next define the relationship between input and output variables, and modify inputs to simulate different scenarios, analyze and compare results. Techniques in what if analysis are scenario analysis, evaluate predefined scenarios, best case and worst case, and sensitivity analysis also we can do, examine how sensitive the output is to changes in specific inputs, how the input variables are affecting the output variables we are finding in a deterministic way is the what if analysis. And applications here are business planning and strategy, budgeting and financial forecasting, risk management and mitigation, system performance evaluation. Here differences between Monte Carlo simulation and what if analysis. Already I said that Monte Carlo simulation is probabilistic and randomness here we can observe, and while coming to the what if analysis, here this is completely deterministic, the outcomes by altering inputs manually, and input type is random samples in the case of Monte Carlo simulation, and while coming to the what if analysis, deterministic, and while coming to the output, probability distributions we can use, and while coming to the what if analysis, specific outcomes for defined scenarios. That means altering inputs to get outputs is the scenario we have to follow. And applications are here risk assessment and uncertainty modeling, and while coming to the what if analysis, the applications are scenario planning and decision support. Both are supporting for decision making, and mostly risk assessment in the case of Monte Carlo analysis and uncertainty modeling are the best applications, and while coming to the what if analysis, decision support is mostly the goal. Next we have verification and validation. So this we can understand by differences. So what is verification? Ensures the product is built correctly according to the specifications is verification, which ensures the product is built correctly or not. And while coming to the validation, ensures the product meets user needs completely, needs and requirements completely need to reach. And while coming to the verification, process oriented, and validation is product we are validating, that is why that is product oriented. Verification is the process oriented, that means that is a process actually. While coming to the validation, we are validating a particular product, so that is why that is product oriented. And next, objective of the verification is check correctness of implementation, and while coming to the validation, check relevance and how much it is useful as the validation purpose. And next one is performed by developers. Verification is performed by developers and quality assurance teams. And while coming to the validation, end user can validate, stakeholder can validate, like that. And next one is timing. During development we have to do verification, and after development, implementation process is validation. And examples for this verification are code reviews, unit testing, integration testing. And while coming to the validation, system testing, acceptance testing, these are the examples for validation. So most importance of V and V we can see here, and applications also we can see here. Next we have simulation, advantages and disadvantages. This you can read. Next one is risk analysis. So this risk analysis is the concept may last in this decision trees. I may not going to say now because you can read decision trees. So what is risk analysis? That first you have to understand risk analysis. So risk analysis is the process of identifying, assessing and prioritizing risks. and that can affect a project, organization or system. It helps in understanding potential uncertainties, how the risk is going on. We are doing analysis as risk analysis, and these also you can read simply and can understand. So risk matrix, and next Monte Carlo simulation, decision trees, sensitivity analysis. These all you can common techniques for risk analysis, or the techniques here we can use like this. These also you can read previously already I said. And while coming to the random number generation, so next one is random number generation. Previously I told that for Monte Carlo simulation to get a random sample, random number generation is the technique we have to use. And here various kinds of problems I provided in the material, so just understand and observe the problems and techniques related to random number generation. This topic is very clear one, elaborated one. You can understand from this material.